everyone, this is Surya from ECE branch second year in VVIT college. My seminar topic is probability definitions and axioms. Now I am discussing about probability. Probability depends upon uncertainty that shows in stock market and weather forecast. Decision making under uncertainty doesn't carry its full implication unless the amount of uncertainty is specified in a meaningful way. The numerical quantity that we assign to a given situation of uncertainty is called probability. So, the concept of probability is considered when a situation or an activity has a certain amount of uncertainty. Probability is all about predicting the chance of something happening. Think of it as trying to guess how likely an event is to occur. Why probability is important? It helps us make informed decisions. For example, if we know the chance of rain tomorrow is 70%, we might decide to carry an umbrella. Let us see technical meaning of probability. What is probability? Probability tells us how likely an event is to happen. One common way to define probability is by observing how often an event happens when we repeat an experiment many times. Let us see types of probability. Probability based on relative frequency. Let's see. We are repeating an experiment like tossing a coin. We are interested in a particular event A, like getting a head. The probability of an event A, denoted as P of A, is defined as the value that the relative frequency of A approaches as the number of trials become very large, mathematically represented by P of A equals to limit n tends to infinity, n of A by n, where A equals to the event we are interested in. N is number of tries. N of A is number of times event A occur in those number of tries. N of A by N it is relative frequency of event A. Let us see one example. If event A is getting a head in a coin toss and we toss the coin 100 times, we count how many times A occur. Suppose it's 48 times. So the relative frequency is calculated as n of A by n, that is 48 by 100, that is equal to 0.48. As we increases the number of trials, the relative frequency stabilizes and approaches a fixed value. That fixed value is the probability of A. Let us see properties of relative frequency. Property 1. Bounded between 0 and 1. Relative frequency greater than or equals to 0 and less than or equals to 1. Property 2. Total adds up to 1 for all outcomes. Summation of relative frequency is 1. Property 3. Depends on number of trials become more stable as n tends to infinity. Property 4 may differ from theoretical values, especially in small sample sizes. Property 5 additive for mutually exclusive events. N of A union B by n equals to n of A by n plus n of B by n. Property 6. Used to estimate experimental probability provides empirical data when theory is unavailable. Let us see classical definition of probability. The classical definition of probability states that that if all the outcomes of an experiment are equally likely, then the probability of an event A is given by P of A equals to number of favorable outcomes to A by total number of equally likely outcomes. Let us see one example. When you roll a fair die, total outcomes is 6. Let event A is getting a 4. Favorable outcomes is 1. Let us see probability of A. P of A is equals to number of outcomes by favorable outcomes, that is 1 by 6. Let us see probability introduced through axioms. In the axiomatic approach, the probability P of A of an event A is defined as a real number that satisfies the following three axioms. Axiom number 1, non-negativity. The probability of any event is a non-negative real number, that is P of A greater than or equals to 0 for any event A. Axiom 2, P of S is equals to 1. The event S is an universal set, that it is a sure event. Therefore, its probability is always 1. Probability of null set is equals to 0. The probability of null event or an impossible event is always 0. Let us see axiom 3. If a sample space An has n events n equals to 1, 2, 3 up to n, where n may be infinite and if all the events are mutually exclusive. Mutually exclusive means two or more events are mutually exclusive if they cannot occur at the same time, such as they have no common outcome. Symbolically represented, A intersection B equals to 5. AM intersection AN equals to 5 for all AM not equals to N, then P of union N equals to 1 to N AN equals to summation N equals to 1 to N P of AN, or P of A1 union A2 union up to AN, that equals to probability of A1 plus probability of A2 plus up to probability of AN. In what this states that the probability of the union of n number of mutually exclusive events is equal to the sum of the individual event probabilities. To simplify the expression, consider just two disjoint events A and B in the sample space F S, then P of A union B equals to P of A plus P of B if A intersection B equals to 5. Thank you for your attention.